Welcome! We're going to be taking a look at Java strings and how we can use methods inside them to work with and do cool stuff with them in programming. So let's go ahead and take a look. So some string details. Before we get started, we want to understand that strings are a fundamental part of the Java programming language. They're built right into it. And the Java string is not a structure. It is not a collection of things. It's not an array. It's not a list. It's not iterable as well. A Java string is just an object. And so all of the Unicode values, including emoji, fit inside the string. And one of the key things we really have to make sure we understand is that strings are immutable. They do not change. You can only change a string by reassigning into the same variable a new set of contents. So once you make a string, it is immutable. So keep that in mind. It's something you want to definitely keep in your brain as we work with strings in Java. In Java, everything can be turned into a string. So every object has a toString method, and you can concatenate any value onto a string, whether it's a primitive or object, automatically. If it's a primitive, it just appends the value to the string, and if it's an object, it just appends the toString method call result to that string. And if you want to find out even more about strings, take a look at the Java String API because it has all the details you could possibly ever want to know about string and more. Here's a quick UML representation of some of the stuff we have inside the string language. We have the AP Computer Science, the CED subset, the stuff we have to actually know for AP Computer Science A, as well as the cool subset that we can use to do some really cool stuff. If you work within the CED subset, you can do basically everything you might want to know, and the cool subset just adds even more stuff to it. And so we'll take a look at this as we go through. So again, we don't need to know everything about the Java string to do programming in Computer Science A, but if you work with what's inside that CED subset, those basic components, you can do basically everything you need to do. And so you can see we have two string constructors, we have length, we have two substring methods, we have indexOf with a string parameter, compare to with a string parameter, dot split with a string parameter, and equals with an object parameter. Those are things you really ought to know. So string constructors, we have the zero parameter constructor, which creates an empty string, aka open and close sets of quotes. So string myText is a new string, gives us a string that has nothing inside it. Okay. We also have a string parameter-based constructor, which creates a new string using that supplied parameter. So I can have myText1 as a new string, passing it words here, so that's the string that's assigned to it. I have string myText2 as a new string, passing it some string variable, which takes the contents of that string variable and creates a new string in memory of those same contents. Or string myText3, which is a new string, passing it myBook.getFavoriteWord, parens, which calls the result of that method of getFavoriteWord and stores that inside myText3. So you have new copies of that same word in that different spot. That's how we can work with strings using constructors as part of this. We have also the string literal. This is possibly the most common way of actually working with strings, and that's creating a string without a constructor at all. It's just any set of text surrounded by double quotes, and you assign that text to a variable or you just use it inside a print statement. So string my name is Cody Henriksen, or string special, even emoji work, and you've got the cute little ghosty. And so that's what a string literal is. You'll see this all the time inside Java programming because it's a great way to simply just type out a string and work with it. When we make an escape sequence, we use the backslash symbol and some other symbol to make the actual escape sequence happen, and these happen inside the actual string literals. We have quotation marks, new lines, backslashes, and tabs. They're the most common ones we see. So to do quotation marks, it's a backslash and a quote. To do a new line, it's backslash and an N. For a backslash, yep, it's backslash, backslash, and for a tab, it's backslash T. So you can use that. You can see that in some code samples as on my other videos, and we'll do that as we work with this as well. How big is a string? So because because string is immutable, you can't change it. The Java language specification uses the word length for that. Specifically, we use the length method. And so each symbol in that string counts, including spaces. So if a string title is Doctor Who, and the length of title is title.length, that is going to be 10 because you have DOCTOR space WHO. Doctor Who has 10 letters, and the space, of course. And so the length of title contains 10. Really easy to work with. The parts of a string. So again, key concept, strings are not data structures, they are a type, and each part of a string is also a string. And so if you want to get only part of a string, then substring is the method used to actually do that. So in Java, the index starts at 0, and so all values need to be in the range of 0 up to and including length when we're working with the substring method calls. We have two versions of substring. We have substring with two parameters, both ints, or we have substring with a single int parameter. So inside, we have substring with two ints. So this is the more refined way of working with substring, that we can get a specific range of values out of that string. And the first parameter is inclusive for that starting index, and the second parameter is an exclusive index, so it doesn't include that value. And this is how we most often get ranges of values out of it. Specifically, if you're using, like, say, for example, a loop, you want to get one letter at a time. And so we can use string current letter, and we have the myString, our string variable, dot substring, passing it index, comma, index plus 1, will get us one letter at a time if index is our looping variable. And this is a great way to work with substring. We also have substring with a single int parameter, and this takes the supplied index to the end of the string. And so if you want to get, say, the last part of the string, like say a file extension or a conjugation of a regular verb, if you have the number that you want to start with, like it would be a variable or a magic number, some literal constant. And so mystring.substring2 is the same thing as mystring.substring2, comma, mystring.length, because this is an overloaded version of the method. So we have mystring.substring2 is the same thing as calling mystring.substring, passing it 2, comma, and then mystring.length. So when you have an overloaded method, it's the same, it does a more refined function of that, as we see with that 2-parameter version. Basic location. So if you want to look inside a string and find where something is, we use the indexOf with a single string parameter. So we want to find where inside the supplied string that parameter is in the calling string. And so it returns a 0-based index for that starting location if it's found within the calling string from its first occurrence. If it has multiple occurrences, that doesn't matter. When we're using indexOf, it's just looking for that one spot right there. If the string parameter is not present in that calling string, the method returns a -1. That includes also if the parameter is too big to possibly fit inside it. So obviously you can't fit a bigger word inside a smaller word, so that would return -1 with that as well. Comparing strings with quality is something you have to definitely understand really well as part of the AP Computer Science subset. It allows you to compare string values as an object. Now, object is a key thing right here. So one of the things to remember is you want to use the dot equals with strings instead of equals equals, because equals ignore case also exists, because equals equals is not the way to compare strings for equality, because you can't guarantee the results on that. So we have me dot equals me, lowercase, is false. Me dot equals capital me, also true. Me dot equals ignore case, lowercase me, true. So those all match. However, me equals me, false, because we can't guarantee those have the same memory address on that. And it's an asterisk because of string pool, it might possibly have the same thing. So we have no guarantee on that. So do not use equals equals when we're working with strings because we can't guarantee the results. So we have dot equals and dot equals ignore case to compare strings for equality. Now, if we are doing sorting of strings, we have the compare to method. And we'll use that when we're working with that. And the compare to uses the lexicographic comparison, aka dictionary order. But you do have to remember that uppercase values are all before any lowercase value. So capital Z is before lowercase a. And so an integer number of less than 0 is returned if the calling string is found before its parameter. So a.compare to b, a negative. Car.compare to cat, negative. Some text.compare to other text because of a capital S is lower. Capital A got compared to lowercase a, case matters on that as well. So we have that compare to, we have to keep that in mind. If it's the same thing, we'll get a 0 back. And so a.compare to a gives us a 0. And if the calling string is found after the parameter b.compare to a, we get a positive number. So b.compare to a or cat.compare to car. We're not cared about the actual value of that comparison, just the fact that it's a positive number or a negative number or 0. So we don't worry about the number itself. You can talk about that and what that means beyond as you do comparisons of that for other more advanced things. But the idea that you have positive, negative, and 0 is what you need to know. Now, if we want to extract strings from strings as a structure, we have a really cool method. This is split. This is honestly one of my favorite methods we have. And the split method allows us to get a string into its component strings and returns an array, a data structure of string pieces based on the parameter you supply to the split method. If you supply an empty string, you're going to get each letter in the contents of each of the spots of that array. If you give a space as the parameter for that split method, you get each word as a value in an array of string. And especially if you're working with data, if you pass a comma as the parameter, you're going to get each entity as an array of string in that. And so those are really helpful to use. And so the split method is really great to take a string object and turn it to an array of string objects based on that parameter of information. Really, really helpful. You can do a lot of good stuff with this. And we'll see how to work with this in some examples later on. If we want to go beyond that, we have some more subset things we have to have. We have contains last indexOf with 2 parameters, the 2 uppercase and 2 lowercase methods, .trim, concat, and to get bytes. And so you can find, again, the Java API for even more information. If you want to look deeper inside the string, the contains method is really great. I just want to know, does it exist? Yes or no? Cool, great. Contains gives me that. It's also great to combine that with .to lowercase because you can look and see if any of that part of the string is in there. It's great for some doing more advanced searches with that. The last index of passing a string is great to get the last time you see something. Now, a lot of usernames contain a dot in them. In my case, Cody.Hendrickson is a common username I have. And so I want to find a dot after my username. So find the last index of that dot will allow me to find, say, for example, the last period inside a file path. Great to do. IndexOf with 2 parameters is an overloaded version of IndexOf. It is fantastic. Okay, you can look ahead and see, oh, is there that same string after where it currently exists? And so I can use this to iterate over a string and find out if there's another string point after that point, so I can then build that and go from there and do some really cool features with that. Great for doing advanced string searching. Now, I know I said this, I'm going to say it again, strings are immutable, but if you want to change how that string looks, how it works, we have some things we can do with that. We have the .to uppercase and .to lowercase methods, which are pretty self-explanatory. It takes a lowercase a, turns it to a capital A for to uppercase, or if it's a to lowercase on a lowercase, it keeps it lowercase, no big deal. However, if you have things like emoji or Japanese katakana or hiragana, there are no cases to those, and so they will not be affected by that. However, if you have other language things, we have like the Strasse in German, we have that can be converted to 2 different letters for that if it's going from uppercase to lowercase. .trim. Do you want to get rid of all those spaces because your cat was typing in the keyboard, you fell asleep and put your head on the keyboard and the spacebar? The .trim method is the one we have for that. It takes all the surrounding spaces before and after the text of the string and squishes them all out. It's great, wonderful tool, I love it. And then .concat. I don't really love this method, but it's amazing. If you don't want to use the plus sign or the plus equals operator when you're working with strings, you can call .concat to build a string that way as well. I like plus and plus equals, but if you want to use concat, it's there too. Finally, if you're working with data, if you want to actually save strings as as electronic data, the get bytes method is the one to do that. So if you're not working with a scanner, if you're working with a stream, for example, then you use the get bytes and you can actually put that into a file output stream, dump those bytes into the stream and save it that way, or read those bytes in and work with them that way as well. And that's what the get bytes method is used for that. I hope this is a helpful way to go over some string methods and get some understanding. Cheers, see you next time, and have a good day. Bye-bye.